Okay, so another topic of interest is parallel and perpendicular lines. Students often struggle with writing the equation of a line that's parallel to another line, etc. So let's start here. Okay, suppose we were told to write an equation of a line that is parallel to this line, okay, and containing a certain point. That's the kind of language that the author is going to use. Like in the homework, they're going to say, write an equation of a line parallel to some other line and containing a certain point. Well, just think about intuitively what you're trying to do. Let me bring up another whiteboard here. What you're basically doing in easy language is you're trying to engineer two lines to be parallel with each other. And if they're parallel, they don't intersect. It really means they have the same slope. So the real thing is, we already know that writing equations of lines we now know is a two-step procedure. One thing is ID the slope, figure out what the slope is, and find the slope. And then step 2 is plug and chug. Plug into y minus y1 equals mx minus x1. Plug and chug into point slope form to help you get the equation of the line. Okay, so let's go back to that first. Okay, so we have an equation, 2x minus 3y equals negative 6. Here it is. We want to engineer a line to be parallel with that, so we'll have the same slope. The question is, what is the slope of that line? Well, if I mold it into mx plus b form, I would know. So let's see, 2x minus 3y equals negative 6. So 2x minus 3y equals negative 6. Okay, just, move 2x to the other side. Subtract it off. So then I have negative 3y equals negative 2x minus 6. Divide every little thing by negative 3. Then you've got y equals 2/3 x plus 2. So one of the lines is y equals 2/3 x plus 2. And you're trying to engineer a line to be parallel with it, so it's going to have the same slope, 2/3. So I'll write this in a different color. So we ID'd the slope. We know little m is 2/3. Okay, we did that. Find the slope, 2/3. Now, all we have to do is plug something here, here, and here to get the full-blown equation of the line. It's like pieces of the puzzle. We know little m, and actually we know the other things too. A lot of people say, what's the x1, y1? So whenever they give you that point that the line is supposed to travel through, that's your x1, y1. So 1, 2. Okay, so 1, 2, note to self, is the given point, and that's what this is your x1, this is your y1. That's what you're going to plug in, okay? So let me kind of erase that last little part there, now that we know what to plug where. Okay, so y minus the y1 equals the slope, which we know is 2/3, and then x minus the x1, which we know is 1. You arrive here on a test, and you got 3 out of 5 points. You're almost there. You got partial credit. Okay, now you just got to keep going. Clean that up. Okay, so when I say clean that up, I mean distribute. So you're basically going to have y minus 2 equals 2/3 x. 2/3 times 1 is still 2/3. So minus 2/3. Add 2 to the other side. Then you basically have y equals 2/3 x. And then whatever negative 2/3 plus 2 is, which is 1 1/3, but you can type it in your calculator if you like. 1 1/3 means the same thing as 4/3, so plus 4/3. Okay, you arrive here, and we're very happy. But now just think about it, schematically. So if I were supposedly supposed to type these into my graphing calculator and take a look at them, would I see what I needed to see? Would I see these two parallel lines? And yes, in fact, we can run that experiment. It's good to get used to your calculator. So I'm actually going to write those down, and I'm going to plug them into my calculator, and I'll show you that indeed we engineered these parallel lines. Okay, so now I brought up my graphing calculator, and I'm going to type in, now be careful, I went to the y equals button, And I'm a little, be careful when you type in fractions. So 2/3, notice I put it in parentheses, x plus 2 was one of the equations. And then in y2, 2/3. Now we know they're going to be parallel because they have the same slope. X and then plus 4/3, but here's the ultimate check. Let's take a look. Zoom, if I hit zoom 6 or standard, that's your standard window to view. Let's try that. So we should have two lines. Look how close they are together, but they're like train tracks, right? They're parallel. Let's zoom in. Okay. Now remember, we had to engineer the one line to contain the point 1, 2. So if I go to second table, see how it says y1 and y2? Let's see if I can write on here. y2 was that equation 2. And notice, when x is 1, I'm going to highlight this. When x is 1, look at what the y value was, 2. See? So the point 1, 2 is contained, or it exists, on that line that we had created. Okay? So it's just kind of another mental check. All right? Let's go back to the graph there a sec. Another cool feature, just to remind you of the graphing calculator, is you can always hit well, I kind of just did that, second table, and you can actually get your table of values for both of those lines. So, all right, I hope that helps, and good luck. Ooh, I almost shut down the podcast without trying an example. That was parallel lines. Now we'll just change the word and insert the word perpendicular. So I did want to try one of those with you. So promise this will be the last one for today. So let's write an equation of a line perpendicular to another line. Okay, so now notice we want to write an equation of a line perpendicular to this line here, y equals 1/2 x minus 1. So let's say this in another color here. Remember something. You're trying to engineer two lines to be perpendicular with each other now. So L1 and L2, they intersect at that perfect 90 degrees, right? So what about their slopes? Their slopes are mathematically opposite. So what does that mean? Negative reciprocal slopes. So the slopes are negative reciprocals of one another. So big note to self, in step 1, when you have to ID the slope that you're going to need for this line that you're about to create is the negative reciprocal of 1/2, which is -2. You could say -2/1 if you like, but you could just say -2. Okay? And then we also want to engineer it to contain this point. So at this phase of the game, we know the slope's going to be -2. So phase 1, we know the slope's going to be -2. And then phase 2, again, is just plug and chug into point slope form, just like we did a moment ago. So y minus whatever the y1 that was given. Remember, this point here is your x1, y1. Okay? So your y1 is 1 and your x1 is 3. And then you can plug in the slope, so little m is your slope. That's -2. When you arrive here, you're pretty much home free. Just have to clean it up. So y minus 1 equals -2x plus 6. Move 1 to the other side. And you got y equals -2x plus 7. So, how do you know you're right? Well, if I put -2x plus 7 in my calculator, say, and this one in my calculator, what I'm going to see is two lines that are perpendicular to each other. Okay? All right. Good luck out there.